When I never felt that, come on, yeah. Never felt that, come on, yeah. When I never felt that, come on, yeah. You gotta get up.
Welcome back to part 2 of chapter 2, section 2. That's a lot of twos. Starting with the water cycle. This particular graphic is in your book. It will walk you through the various different stages from precipitation, condensation, evaporation, and collection. Since you don't look at it and you don't watch the videos, here's the video from your book as well. You do need to actually watch this if you want to do well on the assessment.
And it's just as well that the Earth's inner heat continues to push mountains up. Because huge though mountains are, they're continually under attack. Given enough time, there's a force that can completely destroy them. It might seem unlikely, but that force is nothing more than water. Ironically, mountains create the very rain that attacks them. They're high enough to disrupt the atmosphere and create their own weather. The higher the mountains are pushed up, the higher the air is forced to rise to cross them. So the air cools and condenses into clouds, which produce rain. And it's surprising just how effective the power of water can be. It's only when you're fighting the rapids that you can begin to understand how powerful a river can be. This gorge is hundreds of meters deep, and yet it was cut by the river, relentlessly wearing away at the rock, and it's still getting deeper. Rivers don't just erode the rock, they also carry it from the mountains to the sea in the form of silt. It happens on a massive scale. In South America, the Amazon carries away over 2 billion tons of the Andes every year and deposits it in the Atlantic Ocean. And on the Indian subcontinent, the Ganges River that starts high in the Himalayas grinds away around 1 billion tons of rock every year, dropping it 3,000 kilometers downriver in the Indian Ocean. If it wasn't for the movement of the plates building new mountain ranges, water would eventually erode away all the land on our planet. It's hard to imagine, but if the plates should ever stop moving, our planet would become a water world. It may take an unfeasibly long time, but eventually the land would be worn down and washed out to sea, and Earth would be covered in a vast ocean several kilometres deep. So it's thanks to the collision of the plates continually pushing the land up that we still got terra firma to stand on.
The Southern Ocean never gets any credit. Freshwater is the most important. You can see that it is also the less of all the various different groups of water. We've discussed fracking before. Let's take a look at what it does and what it really is.
In case you hadn't heard, we humans use a lot of oil and gas these days, just a couple of sorts of hydrocarbons, organic compounds made out of hydrogen and carbon atoms. They are a magnificent source of stored energy, running a car engine or a fighter jet or a weed whacker or a power plant. Hydrocarbons are pretty useful. A lot of the world's precious petroleum comes from the Middle East, but that puts a few of the world's countries in the position of having all of the useful oil and gas. So of course, the rest of us are interested in hunting down some domestic sources. And actually, it turns out the Middle East doesn't have the hydrocarbon market cornered. They just have a lot more liquid petroleum than most places. But a lot of the rest of the world has reserves of natural gas. Gaseous hydrocarbons like methane, propane, and butane. Usually found deep underground in giant beds of shale, rock that was formed from the floors of ancient oceans. Natural gas is likely how your water gets heated and maybe even your air. Burning it for electricity is cleaner and more efficient than coal, and unlike oil, when it spills, it just vents into the atmosphere instead of spreading out in huge slicks over the ocean. But the problem with natural gas has always been, how do we get at it? We know it's there, but we can't get it. Well, since the 40s, oil companies have known that breaking up the rocks in deep underground formations can increase the productivity of wells. See, it's not just one big pocket of black gold down there. Oil and gas can occur in thousands of little pockets, and by fracturing the rocks around these pockets, the gas is released and can be collected. Usually, this fracturing involves pumping millions of gallons of chemically treated water into deep shale formations. We're talking a mile or more underground at extremely high pressures. This fluid cracks the shale or widens existing cracks, freeing the hydrocarbons and making a path for them to flow toward the well. So that's how it's done, basically, and some people are so unbelievably pumped about this technology they're building little graven images to it and going to natural gas wells on Sunday mornings. But then some scientists are like, not so fast, you guys, because fracking isn't all butterflies and cupcakes. For starters, it uses a whole lot of water. It takes up to 7 million gallons to frack a single well. And at least 30% of that water is trapped in the shale thousands of feet below the groundwater aquifer, so it's gone for good. And fracking fluid isn't just water, it's sand, which helps keep the cracks open once they're formed, and also chemical additives, which can vary from well to well and are often confidential. These additives do things like thicken the water to help suspend the sand or prevent mineral buildup in the pipe, and some of them are things you might find under your kitchen sink. Others, like benzene and methanol, are pretty toxic. Some concerns about the contents of these fracking fluids, not to mention radium, corrosive salts, and other stuff that comes back up from a mile underground, have led places like Pennsylvania to prohibit fracking outfits from sending their wastewater to local treatment plants. And although fracking, when done correctly, shouldn't contaminate drinking water aquifers, that doesn't mean it hasn't happened. Subterranean systems are mysterious, and it's impossible to tell how interconnected these shale deposits might be with groundwater. If the fracturing is too effective, groundwater aquifers and shale deposits containing newly injected fracking fluid can mix. Although it's hard to say how many cases of contamination have been caused by improperly installed or maintained fracking wells, improperly bored or sealed wells have contaminated drinking water in several sites in the U.S., resulting in energy companies being fined for polluting water supplies. While natural gas is a far cleaner fuel than coal, the fact that it doesn't spill and instead vents to the atmosphere is also problematic for climate change. Methane is a potent greenhouse gas, and if it isn't burned as it vents from fracking wells, it can contribute even more to global warming. And finally, earthquakes. It's crazy, but some U.S. states like Oklahoma, Texas, and Colorado have been experiencing a significant rise in seismic activity, which seems to be corresponding to the fracking boom. Some studies are suggesting that the disposal of wastewater back into used wells are causing the pressurized water to seep through cracks onto old fault lines, causing many more earthquakes than normal, even in places where seismic activity is rare. So fracking, creating a new oil and gas boom in the U.S.? Sure, but it might not be all it's fracked up to be. Sorry, we didn't make any Battlestar Galactica jokes, so if you want, you can put those down in the comments. And if you have any questions or comments or just want to argue about it, the comments are...
Back to the aquifer. I think you're going to like this one.
Hey, what happened to my water?
There's something here that you should know. The story of water from down below.
Oh, I'm groundwater, I'm all around. Most of your water is underground. The water we have is all the same. I'm used over and over again. I surrounded the castle with a watery moat, and I float along under Huck Finn's boat. I once dripped down as dinosaur drool, and now I'm the cool, the bill one stirs. I feed the lakes, streams and land. I'm pulled by wells, I'm in demand. Flowing along, a great bear of treasure, slipping through space too small to measure. I may start off with an oily sheen, but the dirt and rocks help keep me clean.
Swallow and swim, shave and spray. We all use water every day. Some for fishes, some for dishes. But is there enough for everyone's wishes? Use it. Groundwater, don't abuse it. Groundwater, we use our groundwater every day. Let's make sure it's here to stay.
Oh, rainy days, I must lament the troubles I have with tar and cement. I can't feel the ground if I can't get through. I'm groundwater, my power is vast, but waste and pollution keep me from my task. If we're not careful, clean water won't last.
Without some help, we can't carry on. What would we do if the water is gone? Every time you brush your teeth, remember the water underneath. Next time, wait, stop, and think before you dump stuff down the sink. Do your part for water power. Learn to take a shorter shower. Stuff that makes your grass look swell will end up later in your well. Protect groundwater, conserve groundwater as we plan to build and grow. Leave open space for water to flow. Be aware, groundwater, show you care. Groundwater, now you are in the know. Don't forget the water down below. Don't forget the water down below. Don't forget the water down below.
I told you you're going to like that one.